Okay, so welcome everybody, and today we are going to have a basic introduction to the Python programming language. In the last session it was rather theoretical, so we had a theoretical introduction into machine learning and a theoretical introduction into what we're going to learn today in Python. We talked a bit about the Python language, that it's an interpreted language. Here I have what is known as the Python notebook environment open in my web browser. There are some slides available which show you how you can install something like this on your machine. And I will just start by typing some code and explaining basically what this code does. So let me just type y equal 1. What I'm doing here basically is I assign a variable the value 1. If I type the value 1 like this, it's basically an integer value. So this is a short introduction into data types at the same time. So if I type p equal 1.1, then b is a floating point number. So this is an abstract representation of real numbers, which are basically not, of course, not completely real numbers, but which have about here in 64-bit precision, which means they're kind of correct up to 16 points behind the decimal. We have then another type. For instance, if I type c equals something like this, then this here is, as you see, a text, also known as a string of characters. And so we have already 3 basic data types. So we have the integer, the floating point number, and the string basically here defined. Further, more interesting for Python is the list. So let's call it L for brevity, and the list basically can cover all kind of data types, as we can see here. So if I type something like this, and I type then L to see this, we see that the list basically contains 3 elements, and in the 3 elements I have here an integer number, a floating point number, and a string, all bunched together in one object. Also note that basically here in this 2 Python notebook environment, it depends about how it's configured, but in most cases it's shift enter in order to evaluate the cell once you type the code. Okay, so if for instance, how can I access these elements? So let's start it. I type L, then you do these brackets here open like these. And when I type, for instance, 0 with the index 0, I get the first element. And the first element here is 1 in this case. That's the way how this works. If I want to get the third element, as we start to count to 0, I type L2, and we find the third element, which is the string. Okay. As you see, these lists are very convenient. They can buckle up all kinds of data types at the same time, all kinds of objects, because then further, I mean, we don't go into object-oriented programming, but basically YBC in this case could also be objects. And you can all put them into a list together. The thing is, as you can have different data types, this is kind of slow, as this is kind of a linked list. So there's another data type, which is the array. So how to use arrays? We have to import a library in order to do this. So libraries are imported with the import statement. More about it later. Let's import the array library. Okay, we have the array library. I define an array A by typing array.array. So what do I do here? I call the function array from this array library that I imported. Basically, a library is just a Python file with function definitions. More about functions later. In order to define the array, I have to define what type it is. So here in this case, I for integer. And let's do it like this. And we have 3 values that are defined in this case by a list. The list, of course, has to be, in this case, all integers, and it creates an array of this list. The array is basically faster because as the computer knows that they are all of the same type, it can directly address each element just by knowing the size of one element and jumping to the right position in the array. Okay, so we have this array A. Further, there are NumPy arrays in order to get to NumPy arrays. So there are two different kinds of arrays in Python. There are even more complicated things. This is kind of one of the things that are complicated in Python, is that as it's not a strictly typed language, that you always have to kind of know what kind of data type I'm having. So we know right now, for instance, that y is an integer, b is a floating point number, c is a string, a is an array, and we basically have here that each object, so basically you don't know if a, y, b or c what it is without kind of typing it out. There's like a type function in Python in order to find out what kind of type you have, but this is kind of the complicated thing in Python, that you have to kind of have in your head what kind of object I'm treating with. So let's go further. Let's define the NumPy array. So import NumPy. You can see you can rename these functions, so these libraries basically. So here I have the NumPy library. I will import this SMP, so that each function that is provided with the library, I can call it by typing np dot. We will see this in a moment. So I import this NumPy library into our system, and let's define a NumPy array, which is just a different way of writing arrays which have some more handy features. So let's type np array, and let's use the same syntax. So 1, 2, 3, and here dtype. So here you define the array with dtype, and we say we have integers, so we type int, and then get our NumPy array out of here. Okay, so if we type npa, we see this is an array 1, 2, 3, and it's a NumPy array using the NumPy library. Okay, all these types basically, in order to access an element, work just as the list. So if I want to access, let's say, the first element of this array, I can type npa 0, and I have the first element of this list. So how further besides accessing the element one by one, there are several different ways in Python how to work with lists. So we will go a bit into lists and list slicing. So let's type out a more fancy list to play around with it. Let's say I have a list with different data types, as I said, like this, where in the middle all of a sudden I have a string, so I can just handy define a list like this and have a bunch of, let's say, integers and text strings or characters if you want to at the end. This is basically my list here that I want to define, that we can play around with. So if I want to access the first element, as we know, it's just 0, and we have the first element. Okay, so let's play around with this a bit more. So if I want to create a sublist from the list, I can do something, for instance, like this, 2 to 5. Okay, and what do we discover? So 2, basically here, I always check how this notation works. So 2 starts basically as we start at 0 at number 3, but it stops at 3, 4 if you want to. So 5, then basically the stop index is 1 later than the one where we really stop. Okay, if we start counting at 0, so always check, have this kind of notation in mind. What are we doing here? So we get a sublist which is from element 3 to element 4 if you want to, if you start counting at 0, or element 5 if you start counting at 1. Yeah, okay. If I want to store this sublist somewhere else, I can do something like this, sublist, and then it stores this part in my sublist. And if then I kind of have sliced the list from this point to this point. There is even more fancy things, so I can do something like L 2, 8, 2. Let's do something like this. So we start, what will happen if I evaluate this? So let's evaluate this. And what do we see? So we start at element 3, here. So at element 2, if you start counting at 0, we go to 1, 2, 3, basically 2, 4, 5, 6, 7, to element 7, maybe 8, 9, if you want to. And we take every second element. So this here is the beginning, the end, and we take every second element out. And what do we get? 3, 5, test, and then we stop. Okay? This is how this kind of syntax works. Something else that we can do to get with this fancy syntax further, we can write something like L, and then we can do something like just double point 3. What will this do? And as you see, it gives us the first 3 elements of the list. So if you want to have, I don't know, X number of elements, and just from the beginning of the list, you can just use this syntax. Okay. Something else, so getting all elements, for instance, but the first 2, let's do something like this. We can write something like this. Okay, and then I get all elements but the first 2. Okay, so here we start at 3 and we go over till the end of the list with this kind of syntax. So this is fancy how you can very quickly slice lists and get elements out of a list using this kind of syntax and notation. Okay, further, something else like the lists, there are also tuples. So what are tuples? Tuples basically work like lists, but they are not mutable. So in a list, basically you can exchange the values that you have in a list, you can extend the list, append to the list, change the values that are inside. The tuples, once you have defined them, they will stay there forever. So how do these tuples work? So I write here tu for a tuple if I want to have this, and the tuple basically uses a different kind of brackets. It also works like a list, so you can have all kinds of different data types inside. It's just that they are not mutable, so you can't change the data that basically is inside this tuple. So if I do this and I evaluate this and I do t1, what will I get out? In this case here, nothing, because I write it t, but I have to write tu. So basically we get tu1 is of course 1 because we evaluate the first, the second element by writing 1 as we start at 0 to count. Okay. So something else, for instance, just to get this mutability. So if I want to exchange an element in the list, I can just access it by its accessor. So let's say L3, what is it? L3 is currently 4, so if I say L3, I want to make it 10 or something else, or as the list basically covers all kinds of objects, I can write in here whatever I like. But let's make it 10, for instance, and then if I type the list, you will see basically I get 10 at the position where I exchanged my value here. If I try to do the same thing with the tuple, so let's try to exchange the first value of the tuple. Here I did the list, I'm sorry, with the tuple, as I said. Then we see that this doesn't work because the tuple is of course immutable. Okay. Then there's kind of typecasts, so you can basically change from the data types that I've shown you right now, from one data type to the other. This comes handy, for instance, if you want to print a number, then you want to convert it into text before you print it out, and vice versa. So let's get into this. So let's define something like this, and then basically we have this 1.1 written as string, as I put it under these quotation marks. If you double quote a quote in Python, it doesn't make any difference. You just have to have it before and at the end at the same quotation type. So let's define this here, and then we have basically C is in this case a string of 3 characters. So where these 3 characters are of course a number, but more to that. So if I want to convert this to a floating point number, I can do something like this. Okay. And then C is not a string anymore, but a number. Okay. You can then further this floating point number, for instance, if we would have done this in the first case, we can do something like this. And then we can convert to an integer, and we see that basically everything behind the comma is lost. This always happens like this, so basically it just cuts it doesn't round, it just cuts basically the comma part, okay? So just to keep that in mind if you do this. Okay, some things that you can do with a list, or with even several other objects. Let's say I have a list of the same data type. This of course only works if the list contains things of the same data type. So if I have here these kind of numbers, I can do something like this. Okay, so this is a function of the list. This is kind of how it works in Python. This is part of object-oriented programming if you want to, because the object L contains the sort function, but it applies directly on the list, and if I do this, we see that then the list is sorted. Okay, fine so far. Of course, if I would have a long list as we have it before, so let's evaluate it in this IPython notebook environment. You can just scroll back if you want to and evaluate, for instance, an old case, and then it changes the state, so it's kind of in this IPython environment kind of state-based if you want to. Yeah. And if I go down here and right now I type L, you see that I still have the old list that I just evaluated above. And if I want to sort this list because it contains different data types, it will not work, and you get an error, as you see, because it can't compare basically strings with integers. Okay. Okay. What else can you do is you can just rememorize the syntax for all, because for more objects than just lists and arrays and all these kinds of stuff, more or less they all use kind of the same syntax, which is reused and reused. So if I want to get rid of an element, for instance, I want to exclude, let's say, the third element here, which basically we start counting at 0, so it's the number 4 probably. If you do this, I remove with this L the number 4 of the list, because it's the element indexed with the index 3 as the index starts to count with 0. Okay, so if I do this, we see we get back the number 4, so we could have stored this in a different variable. We will show this quickly. So if then I do something like this, just let us check L, and then if then I would do something like let's say upper, I will call it like this, so that it's not part of the list, and we do have here basically we can do something like this, and what will happen if we do this, so L then looks like this, and I still have kept my variable because I stored it in this other variable, and I still have basically the contents that I have pushed out of the list to some variables. Okay. What else can we do with the list? We can of course append to a list. So let's do something like this. So let's take our list and append an element to the list. Basically we have here the value, let's say call it E to have some fun here, and then if we evaluate A, so we have appended and it adds it at the end of the list, basically this element with this append function. Okay, so something else is what happens, for instance, if I do this. So let's say we have a list which we call here, let's make it like this, C and D, okay, and we have this little list here, and then of course if I do L append C, what will happen? Let's imagine it. So as you see, what happens here is that I kind of get a sublist in the list. So basically we have a list element, which is a list in itself, and this is of course in this case probably not what we want. So what would we have to do? We can basically remove this object by doing something like this. So of course we can use this pop function, and we have then, I have to count it where we are, so 0, 1, 2, 3, 4, 5, 6, 7, 8. If I count it right, it should be 9. Let's try it out, and we see, okay, we have removed, because it's just one element, the sublist from this list. So how can we edit then in the way we want it? We can use the extend function. So if we do extend, we can put a list into this extend function, and then we get out what we actually wanted. Probably we have the list elements of this middle list extended to this list, and we kind of concatenated these two lists to one. Okay, something else that you can do is you can also index the list from behind. So if I want to get, for instance, the last value, I can do it with using an index like this. So right now I get the value d out. If I want to get, let's say it's something like that, then I get the value e out. As you can see, just to note that this here is of course not starting with 0 but with -1, because otherwise this would not be possible in this kind of syntax, and we get basically these two elements out of it. Okay, we also, something else we can do with these objects is we can insert something, so we can do something like insert 3D, and let's see what this does to us. So let's evaluate this. Let's show us our list, and we see we have inserted at the 4th position, because again the index starts at element 0, the letter D basically into this list. Okay, that's basically it for so far. Right now that we worked with list, almost the same syntax, as I said, works for many other things in Python. You will see that this pop basically comes up later again. Also, so several types of this basically are recurrent, and also the accessors basically with these brackets were kind of the same way. We come to the NumPy array. So let's talk a bit about NumPy arrays. Let us create first a list to start out with this NumPy array in a manner that it has like 9 entries, to have some fun with it, so that we find out how things look like, how things work. Let's just put each element integer corresponding to this element, and have 9 elements like this, so that we can play around with this. Okay, so we first created a list. From this list we can create our NumPy array, as we have shown with np array. This is kind of a data type that as a data scientist you will use very frequently. That's why we kind of point it out here, and how you can play around with it. Okay, so as I said, the array has to contain always the same data types. Let's create this. Okay, so we have our type here, and we can see, for instance, these NumPy arrays, they can have dimensions, they can look as matrices or even as tensors in multi-dimensional ways. Something like this. So let's see what this looks like. So if I type here in how much dimensions I have, we can use this accessor here, and we see we have 1 dimension. The second thing that we have here is we have something like an accessor which looks like the shape, and the shape here tells me, okay, I have 9 elements in this first dimension. Okay, fine so far. Something that you can then do is, for instance, I can do something like, I have to store this, because if I just call this reshape accessor that I will just call, it will just point it out, but it will not apply directly on the array. And in order to store it back to the array, basically you have to put this equal sign in front of it, so that it then applies it and stores basically the modification without just highlighting it. Yeah. So if I do this like this, I can of course do this because I have 9 elements. Of course, the things that you have to make sense, and if you have 9 elements, you can write them as a 3x3 matrix, which is basically what I did with this. So what happens right now if I type n-shape, I find out, okay, I'm in a 3x3 matrix. Okay, what does this look like? Let's just watch at n, and we see basically that we have created a matrix with these 9 elements as they are in this NumPy array. Okay. Something else that I might be interested is what is the type of my array that I've created. So there is this t-type accessor, and with this t-type accessor I basically see that this is int64, which means it's integer numbers, and they're stored in 64-bit, which is a bit much for these numbers, but it doesn't matter. So basically I'm using 8 bytes per number that I store to find that out. Yeah? This can also be shown by item size. So if you want to know how much storage, if you then work with larger NumPy arrays, if you store a lot of data as a data scientist, you need to know how much memory basically your arrays use. So here I see how much memory one item of my list uses. If I type an item size, I see it's 8. So I store basically 8 bytes. This is bytes, not bits. 8 bytes. Here it's bits. Here it's bytes. So 8 times 8, 1 byte, so 8 bits gives 64. Here the item size is 8. It's 8 bytes per element. Yeah. If I want to see how many bytes my whole array stores, I can do something like n bytes, and I find, well, 8 times 9, as you guessed, it's 72. And I store 72 bytes with my little matrix that we have created here. Okay, so let's go back to our old shape. How could we do this? So we can do reshape again, and we can just type 9, and we see then we have a one-dimensional array with 9 elements, and we get back to what we have started from. Okay. Things that you can do with these NumPy arrays is you can split them, you can basically play with them around, and there are very handy functions that you can use as a data scientist. For instance, if you want to have training and test set splits or things like this later on. How do these things look like? So we can, for instance, split this array. So I will do something like this, split, and I say, okay, 3, what does this look like? I'm sorry, I should have written here NP split. So you see, we get here the index again, it starts to count at 0, so I split at the 4th position, okay? And I see, okay, I get 2 arrays in a list, split it out, where basically I have the first array, which is the first element of the list, and the second array is the second element of this list, okay? Okay, let's play a bit more in two-dimensional space. So let's go back to this two-dimensional matrix. So how do we do this? We reshape by 3 by 3 as we did before, and we see we have our little matrix, and then we can, for instance, not very intuitive, but there is H split, which kind of splits, sadly as it is, as I said, not very intuitive vertically. So if I do something like this, we see that we get a list where the first element is kind of here, as I said, at the second row I want to split. Okay, so it splits basically between the first and the second column here. And we see that basically we have an array containing the first column vector here of this matrix, and another array containing the second 2 column vectors. Okay. This is the H split. Of course, there is also the V split, as I said, rather counterintuitive, because this is cuts kind of from my perspective vertically, while the H split cuts by the V split, sorry, cuts horizontally. Yeah. So V split. Let's do this, and let's see basically what can I do here. I can type 2, for instance, so that you get some kind of an intuition how this works. So we kind of cut here between the second and third row, as you see, and we get again a list with this submatrix and with this vector here spread out as a NumPy array in this kind of notation. Yeah. Just note that here this array is still two-dimensional. Just to point this out with these 2 brackets. Also here, as you see it, with these multiple brackets as they are laying down here. Okay. Okay. So far. Let's go to something else. So this is kind of let's say it here, the kind of data shapes part or a data types part is kind of finished. We will go over to loops in Python and how you can loop and execute code multiple times. So let's create a little list again in order to highlight how all this works. So do we still have our list? So we have our little list here, and we can, for instance, play with this list, and we can do something like for I in L. And what does it do basically? It executes then the subsequent code, which has to be indented, so it should be like one tabulator inside. Please make sure that in Python indenting is kind of necessary. It's not like in other languages, something which is just out of convenience. Python enforces indenting. Without the indentation, the code doesn't do what it's supposed to do. Yeah, so you have to indent. You don't write any brackets here to start the loop as in other languages. You just indent the code, and the Python language automatically gets it that this is the stuff to do. Yeah. Okay, so we create our loop. As you see here, it automatically pushed the tabulator for us. If I would get back, I'm already outside the loop. Okay, so what I want to do, I want to execute some code all the time, so I use just the print function, and I evaluate the print function for each element in this list. So each element in this list, what will it do? It creates, of course, this, so for each element it prints it, okay? In this case, like very easy to understand this. Something else that we have are ranges. So ranges are kind of iterators in Python. They are very handy to use them with the for loop. I can create something like to write this. Also, not forcibly intuitive is that this here goes, if I write here 8, it goes from not to 8, but only to 7. It starts at 0 again. So let's get this out. So let's check it out to see what it does. So if range 8, we see it goes from 0 to 8, and it always increments 1. Actually, it doesn't go from 0 to 8, but you will see it very quickly. So let's just get basically how this works. We can also define this to a variable and use it kind of like a list. So I can do range 0, 8, and then if I type 8, 3, for instance, I get out the value 3, as this is kind of the setting it starts to run at 0. Okay. Let's see how we can use this. So for I in range 8, let's do it. And then, of course, I told you we can use these accessors, and let's do something like this. So we take our list and we access the value I. So using the value I, basically, so in this range, as I said, it goes from 0 to 7, probably. We'll see what happens. And we get basically the first 8 elements out of this list that we have created. Okay, starting with 0, of course. Yeah, okay, because we had in the list 0. Okay, you get? Okay, perfect. The next stuff that we want to show you is the while loop. So the while loop, for this you also have to learn Boolean operators. We will just do it learning by doing here. So let's write some code like this. So let's say we have an integer which is the value 0. We do our while loop, which looks like this. Okay, and we do I, and then we do something like this. Okay, so just recap a bit what's going on. So I set the value I to 0. I run this loop. So this loop basically it executes this code until this condition is satisfied. Okay, so as long this here is true, it will run. If this becomes false, it will not run. Okay, so as long I is smaller than 6, it will run. It increments I each time. So what will happen? Let's run it, and we see we go to 5 because as soon as this becomes 6, it doesn't continue to run. Okay, fine. Something else that we have here in this in this story is the continue statement. So to point this a bit out, how you can play with these loops. Let's do something like this. Let's take our loop again. Let's do something a bit different. So we have here I plus 1, and then we do if this I equals 3. Yeah. Please note here that in this kind of Boolean operators that we have here, that if I want to check if a value equals another value, you have to do this equal sign, which basically says, okay, if it equals, so this basically returns true or false, while a single equal sign kind of maps the value that comes out here to the variable that is on the other side. Okay, so this is an assignment, this is a true or false check. Okay, fine. Print, we do something like continue, okay, and we write continue, and then we go back from this if, so this is outside the if, this happens all the time, okay, and what will happen, just to check this out. So basically, if this is 3, it writes continue. It doesn't write 3 because we have the continue statement here, and the continue statement basically makes it so that it doesn't continue in the loop, but that it jumps back to the beginning of the loop. This is kind of the story of this continue statement, which is sometimes very handy. It basically doesn't evaluate the loop to its end, but it continues from above. Okay, so as you see, we write 1, 2. Then continue because this here is 3, okay, and then 4, 5, and 6. This is kind of how this code here works, okay? Fine. What else can you do? Just to recap a bit how this works. So if I say I equals 5, okay, let's play a bit around with this Boolean operator. So if I write I smaller than 6, you see this here is kind of also like it works like a function, so it gives back the value true, which is a value inside Python. Yeah, it's a data type, it's a Boolean data type if you want to. And we have, of course, for instance, if I say test is I equals 0, in this case it gives false. Okay, you can store these values. So for instance, if I want to do C, let's write it like this. Just so that you note another Boolean operator that comes very handy. So if I have this not value, this is basically I is not equal 0, and this then returns, of course, true because it's 5, and it stores this value in the variable C. And if then I type C, you will see that it's true, okay? So you can use even these Boolean operators like this. Just to check this out, okay. You also, of course, when we work with these operators, you can merge them, so you can have multiple conditions. So you can say something like A, for instance, equals 10, and I don't know, and B is not the letter test. So you can evaluate things like this, and it gives back true and false, as you like, as you imagine. Okay. You also have and or statement like this. Okay. Fine so far. After loops, after this little introduction to loops, so what do these loops do? They basically allow you to run subsequent code multiple times, as just shown here. Something else that you can do is you can define functions, and functions, let's look quickly up how you define a function in Python. So my function is basically recurrent code that you want to use multiple times in your Python environment. How does this work? We define a function with the def statement. So def, and here I make a function like addition with 2 by default, so that we can play around with it a bit, so that you get kind of the notation of how to define a function in Python. And we can, let's call this layer variable A, and then we do variable B, and we write here equals 2. Okay? So by default right now the variable B will be set to 2, but you can kind of change the way things are going. Okay? So let's do it like this. So we do something like C equals variable A plus variable B, and then we return C, and we have our function defined. Okay, so right now we have this kind of code here written. Of course, functions normally are longer than this, but this is just a little toy example in order to point out how this works. What it basically you can do is you can write a .py file, and you can fill it up with these functions, and then you can import, if it's in the same folder as where you run your IPython environment or your Python script, and you can import basically the file, and then you get all the functions with the file name and basically the function name. Yeah, and you can rename these functions. We will show this later. Let's try this out. Let's try something like this, result, and then we use this addition with 2 by default function here, and let's say we use basically, let's say we use 5 and 3, okay, and then we do result, and we get out 5 plus 3, of course, is 8, as we do here. If we do something like this, and we write here, let's say 3, what do we get then? This works, and you see we get 5 as it's by 2 by default. How did we get by 2 by default? We set variable b equals 2, and if you don't override it like this, it automatically is 2. Yeah. Also, we see that these here are named variables, so basically we could write something like here variable b equals and variable a equals. If you do this here, normally you write it in default order. Otherwise, then you can just, if you have like a third variable that is not defined or that you want to redefine, you can just write the variable name equals, and then it will be overridden by the variable name. Okay, so much into functions. You have seen how you can define functions, how you can use functions. Right now, let's go to this import. So basically, as I told you, you can import functions. So if you would have written all this in a .py file, this statement here, then you could have import the .py file. So the name, just write the name of the file without the .py, and then basically you can import the function from there. I will show you this from this math library, how this works. So I can, for instance, import math, then I get all functions from a math.py file, which is kind of somewhere stored probably on my computer if you want to. Okay. In this math library, basically we have the sinus function, and if I then type math9 we get of course the sine of 2, which is this floating point number that comes back from this operation. What we see here is I have to write math.sine. I can just import only the sine function if I want to. So I can write something like this: from math import sine. And then if I type sine2, I don't have to write the math.point here, okay? Because I imported just this function, and this function then gets the name as this. We can also rename this, so we can play around with this, so we can do from math import sine as sinus, for instance. And then what it does, basically, if I stored, for instance, here this addition with 2 by default in this .py file, I can rename it by saying from my file name import this as just addition, and then I have a function which is called addition. So just let's try it out with the sinus stuff here. So if I have sinus 2, we see that the sinus 2, of course, works like this. Okay? Okay, so good so far. Another data type that we haven't seen so far to finish the data types is and this basic working with Python is the dictionary data type. Yeah? So the dictionary, it works a bit like the list, but we can basically name our elements. Yeah? So how does this work? So I will call it here just dictio for a dictionary data type, and we do something like this. So we do name, for instance, Peter, something like this. Let's create something like this, and then we have here a second value, for instance size, and Peter is maybe, I don't know, 1.75 m, so let's do it like this, and we have created our dictionary. Yeah. So if I want to access, then for instance of dictio something like this, I can write something like this and get to this object. Okay, so it works kind of like a list, just that I kind of name all my stuff, and I can of course use this element and put a list in here and access the list by just putting the name of this object. Okay, this is how dictionaries work. Very easy, very simple to do, and we stop here for this video, which is about data types and introduction to data types and the basic introduction to Python. And then we will go in the next video about where we learn basically how to write files to files, how to read files, and how to work with files, and how to use basically also CSV files in the pandas environment. Okay, thank you so much. That's the end of this video.